अभी तक क्वेश्चन ही नोट किया है। What is the first step? You need to calculate the expected value of C, that is mu C. So you will use the first order approximation. What is the first order approximation? Just check for the case of multiple variable. But just before we did for two variables. Here how many random variables are there? Two, R and V. So problem is almost, we have almost solved. So now you need to just plug in the values, right? And tell me what is the mu C? 0. Mu C 0.635. इतनी जल्दी कैसे आ गया तुम्हारा आंसर? किया क्या? ये याद अच्छा, इसके बाद सीधे मीन वैल्यू डाल दिया। See, simple formula has, we have shown the formula just above, if you see. But you need to use second order approximation for mean value. What you have done is first order approximation. What is first order approximation? First you will get, what is first order approximation? That mu C will be equal to, no, what is the first order approximation for mu C? Mu R plus mu V minus mu R mu V. This is first order approximation, right? What is this value? Point. This is first order approximation, right? Now what is second order approximation? Mu R plus mu V minus mu R mu V, and then plus check into your notes, check your formula. Yesterday we derived it. First tell me. First you can write like this, right? Half summation I equal to 1 to 2. Summation j equal to 1 to 2. COV xi xj del square g del xi del xj, right? Now what is x1 is R, x2 is V. What is G? G is nothing but R plus V minus RV, yes, see. So what is del G by del R? Del G by del R? Del G by del R is 1 minus V. What is del square G by del square del R square? 0. What is del G by del V? 1 What is del square G by del V square? 0, right? Now only thing, and what is COV? What is COV RR? What is COV RR? Sigma square, right? Sigma square R. What is sigma square R? 0 point. What is COV VV? 0 point. Right? What is COV RV? What is COV RV? No, you have to tell me. I know it is written there. 0.015, right? Now in this expression, this is first order approximation, right? In first order approximation, only you need to add these terms. And what are these terms? These terms only, half. First will come when I equal to 1, j equal to 1. So sigma square R del square C by del square R square. Then I equal to 1, j equal to 2. And I equal to 2, j equal to 1. 2 times COV R comma V del square C del R del V. Then I equal to 2, j equal to 2. Sigma square V del square C del V square. It's okay, it's okay, it's okay, it's no problem, just go. Right? Only now you need to plug in the values and let me know what is the value of second order approximation. Give me the second order approximation. .635. So now tell me, what is the percentage difference between the first order approximation and the second order approximation? Percentage difference, how will you calculate? This minus that divide by this, because this is more accurate. Tell me what is the percentage error in the first order approximation compared to the second order approximation? Percent, 2.36%. So it's not much, right? So we can work even with the first order approximation also, right? Now first order approximation of variance of C. First order approximation of variance of C. So first you need to write the complete expression and then put the values. First order approximation of variance of C. First you tell me what is the expression in terms of variance of R, variance of V and del C by del R in this form. First write variance of C. Variance of C. Expand it. अरे वो कहाँ गया? कोवेरियंस वाला टर्म कहाँ गया? कोवेरियंस का टर्म नहीं आएगा ऐसे तो फर्स्ट ऑर्डर में कोवेरियंस तो आता ही है वेरिएंस ऑफ आई में। दो वेरिएबल हैं, अभी तो ही कराया था। ये कहाँ गया? ये दो अभी मैंने कराया जो एग्जांपल, ये कहाँ गया फंक्शन में? ये वाला होगा ना, है ना? Just before starting this class, I solved one 2 variable example, right? It is the same thing. Show me expression, variance. Okay, very good. Yeah, you got it. तुम्हारा क्या नाम? विवेक। अरे सीधे उसको एक्सपेंड ही तो करना है एक्स वाई वाले को। You already have all derivatives. Why you are doing again? Tell me the value of variance of C. So what is the expression for variance of C? In the expanded form, it is coming out to be variance of R del C by del R whole square plus variance of V del C by del V whole square plus 2 times COV R comma V del C by del R del C by V. Right? This is the expression, right? Now if you plug all these values, what answer you get? What answer you get? I think this example clearly explains the application of this idea of approximation, right? I think next time I will just write, when next time I will teach this course, then I will write this everything in a book form, and then I will circulate that book and I will say, okay, you go read and come and ask questions. Flipped classroom. Will that be okay, or should I come and then I should explain that? That will be better, na? Or what should I do? Should I circulate that and students can come in the class with the soft copy, and then I keep reading, I keep explaining line by line, and they can solve the example, I will solve the example line by line. What is better option? Or just like this? No, I will teach. See, of course I am going to teach, but what I want to know, what will be more better learning experience, that by, so right now I am doing this because I don't have printed notes, right? Once I have the printed notes, then basically no need of this. But sometimes some of the things are more clear in the slides, some figures, nice figures and all those things. I point like this and explain. So there can be two options. I just give and then I read line by line. At the same time I explain also. What will be better? What do you think will be more interesting for the students? Board work I will do. Board work I will certainly do. But right now what I am doing, some part I am explaining here, then I am doing the board work, right? I think in my course I have done the sufficient board work, right? But what I am asking, next time I should not show the slides, I should give the handouts. And then in the class, instead of teaching by slide, I just read the handout. And if there is any calculation, I will start explaining on the board without putting this slide business. What do you think? That will be better, or this is better? What is more better? Slides are better. But what you can do means, suppose if you take the printout of handout, or suppose if you have the laptop, so you can directly highlight that particular point and you can write the explanation there. Notebook is always better. Okay. Okay, and that is true. So notes should be there. Okay. Okay, chalo, dekhte hain. So what is the answer variance of C? 0.0326, right? You are getting. So now, variance of C. How many of you are getting this number? Raise your hands. 2 persons got. You also got? What is the problem? Mu v, these all derivatives are at mu value, right? See, these derivatives where you are taking? At mu, right? A whole Taylor expansion is about mu. Getting? Not getting? Okay. Now you tell me, what is the coefficient of variation of C? What is coefficient of variation? Sigma C by mu C. So what is sigma C? Square root of this. What is square root of this? Zero point 0.18. What is mu C? You already estimated. Point. Now multiply by 100. So what you get? 28.4%. Coefficient of variation in C. What was the coefficient of variation in R and V? What was the coefficient of variation in R and V? Coefficient of variation of R and V. How much? 33%. V में 40% and C में 28%. So what is happening that if there is an uncertainty of 33% in R and 40% uncertainty in V, then net uncertainty in C is 28% coming out. Okay, so engineer wants this kind of idea. Engineers know that my input is that much uncertain. Can you tell me how much my output will be uncertain? So this answer is being given by this kind of approximate analysis. It is so powerful. I am just telling, if your R is 33% uncertain and V is 40% uncertain, then your C will be 28% uncertain. Right? So this is something that is giving you a very clear idea. Okay? So why covariance is more?
Uncertainty C should be more than
Compared to their individual, right? But why it is coming out to be less? Because if you see the expression for C, if you see the expression for C, there is R plus V and then minus R into V. Now, please, because you asked this question, let the expression is R plus V minus RV. Let there is an error in R, epsilon R, and error in V, epsilon V. So can you solve this and let me know what you get? Can I write like this? Right? Can I write like this? means the error or the uncertainty in C depends upon the error of R, error of V, and the mean values of V and R. They are explicitly depending upon that, right? It means it will depend whether your uncertainty in C is going to be higher than the uncertainty of R and V. That will depend upon the mean value of R and V. If there is a different value of mean R and V, this uncertainty may be higher, may be lower. That's why mean values play a role. Now, suppose this function had been only R plus V. Then what would have been the error in C? Epsilon R plus epsilon V. In that case, it is not depending upon mu R and mu V, and then their errors are just adding up, and then the error will be higher in that. So it depends. Sometimes your error will depend upon the mean values of the parameter itself. Same function will give different error ranges at different values of the observation. Right? Did I answer your question? So now take home exam I have already explained. Explanation and problem statement is in the PDF that I have uploaded. So now you can keep working on that and strictly follow the deadline. Now we are coming to start the new chapter. And that new chapter is because of these things I have started hating this PPT kind of teaching. This will stop, and then sometimes I'm not able to use that part of the board. I have to rub a lot. Okay. Bootstrapping. What is bootstrap in literal sense? Boot means shoes, right? Strap means fita, and strapping means locking the shoes, right? Okay. So bootstrap is kind of a method in which you don't have any idea about the probability distribution. It is something like Monte Carlo simulation without probability distribution. As simple as that. So suppose you have some samples which can fit in your shoes, right? Some samples that can fit in your shoes. Now you are strapping it. So it means based on that data which is contained in your shoe, in your boot, you are strapping it, and just based on that you are calculating all the statistics. You don't need to go to any probability distribution. And idea is very interesting. This idea came very recently in 1970s, and it took a lot of time for people to get to accept this idea. But now it has become a very interesting topic among the engineers. The idea is so powerful. What says, suppose you have gone on the field and you did some experiment, you collected some data, right? Now you don't know probability distribution. So what you will do? You will say, okay, I will plot the histogram, I will fit the probability distribution, but that is also has epistemic uncertainty because you are fitting some kind of distribution, some idealization. But in reality it may not be the idealized one. You can force it, but it may not be always reality. Then what you will do? How will you get the statistics? So what they do in bootstrapping, that okay, this much sample you have, okay, now you start playing with the sample. You say, suppose in that sample I have 10 values. So out of 10 values, you can extract how many samples? So suppose there are, it is something like that, suppose these are your samples. So one test result put here, here. So how many? 1, 2, 3, 4, 5, 6, 7, right? So suppose how many ways you can fill this particular box with sample? 7, right? 7? No, why 6? Suppose you did some experiment, some random experiment, okay, and you are getting 7 different values, right? Now you have to play with them, permutations and combinations, and create some hypothetical samples using only those values. So the same value that come here can come again here, because it is a random experiment, and all of them are coming some unknown probability distribution. So this number can appear again, right? 7 this, 7 this. So total how many samples you can create? 7 power. How much is this? Eh? 8. This much, right? 8 lakh samples. 8 lakh samples. Almost 1 million samples you can form. In Monte Carlo simulation, how many samples we formed? 1000. That coming from probability distribution. Even if you select randomly 100 samples by doing this kind of jugglery, that can give you a very nice idea about the statistics of that kind of data, right? That is the basic idea behind the bootstrapping. It is saying that you have some data which is coming from some probability distribution. So if you draw the samples from probability distribution, so whatever data will come, suppose the same data is coming all the time in different sequence, different forms, multiple times. It means if you collect all of that, it will give you that part of the probability distribution. It means it is going to give you the statistics of that. This is the basic idea behind the bootstrapping. Without using any probability distribution, you just same thing you use in different combinations. Bootstrapping is a powerful technique that can often be used when you don't know enough about the underlying process or the nature of the distribution. A quick and easy alternate to Monte Carlo simulation. For Monte Carlo simulation, you always need to know some kind of random distribution, right? Otherwise it cannot work. A non-parametric procedures, as it does not make specific assumptions about the form of any underlying probability distribution. This is a non-parametric approach, bootstrapping, because it is not using any kind of function. Monte Carlo simulation is using a distribution function. So this is a non-parametric approach. This was proposed in 1979 by this guy Efron, and it took a lot of time, but now it is very popular. So directly from the book of Efron, I have taken this figure. So this is very important figure which explains. How much time is left? 5 minutes. So I will just explain this figure. So this is the data set of n samples, right? So from that n sample data set, you are collecting different subsamples by doing this kind of phenomena. So one set that is coming out is known as x1 star, then x2 star, x star b, right? Then from this sample you are calculating the mean value. Then from here again you are calculating the mean value. Every time mean value will come out different because this sample sequencing is different, right? Sometimes some samples will be repeated. It may also possible that some of these values will be equal. Okay, some will be different. So here you are calculating sample mean all the time, right? So here you are getting the distribution of, or you can say the random samples of sample mean from single data set. So that will give you the expected value of the mean and standard deviation of the mean. So what was standard deviation of the mean? Sigma by root n. You remember? Variance of the mean. Similarly, you can calculate the standard deviation of all of them. So from that you can get the expected value of the standard deviation and standard deviation of the standard deviation, right? If you remember, I told only one formula, sigma upon root n for the sample mean, but I never told any formula for the sample variance. Why? Because it was very complicated. It involves higher order movements and very complicated to calculate. So how one can do that? Using this. What was the standard? What was the distribution of the sample variance? Okay, what was the distribution of sample mean? Student is, what was the distribution of sample variance? Chi-square, right? So now you don't need to worry about that. You can simply get the values from here. Only one value of mean, only one value of standard deviation. That is okay, but you know that mean has an epistemic uncertainty of sigma by root n. How will you get that sigma of the mean? These are random samples. This is sample, not the population. This sample itself is coming from some population. Yes, that's what I told. That's what I taught. That's why it follows a student t distribution. I think you need to revise your old notes. Mean is a random variable. Okay, so see you on next class, in the next class, that is on Friday. Then we will explain this bootstrap with codes. Only the mean of the population will be a deterministic variable, but mean of the sample will be a random variable. That's why when we take the expected value of mu c, it is mu c, because that is representing a population.